a routine correction buried within the endless stream of stellar data pouring from the Gaia Observatory. A minor adjustment, the kind that slips unnoticed through the machinery of the cosmos, became the quiet spark of something that should not have been possible. In the data, amid the pulse of countless suns, the Milky Way folded upon itself. The distances that once stretched with comforting vastness began to collapse, as though space were drawing a breath inward. For centuries, humanity had looked up and imagined itself surrounded by infinity. The galaxy had always been a monument to scale, 100,000 light-years across, a spiral of ancient light and mathematical grace. But what if that immensity was a mirage of perspective? The recalibrated models did not shrink the galaxy by a factor of miles or parsecs, but by meaning itself. They suggested boundaries, edges where there should be none, gravitational gradients bending not outward but inward, like the curved walls of an invisible chamber. Astronomers hesitated to call it a discovery. They called it an anomaly, the gentlest word science uses when it glimpses the impossible. Yet the numbers persisted. The Milky Way was not simply smaller, it was confined, curved in a way that defied expansion, as though the light of its stars had been folded into a luminous shell. It was a heresy spoken softly among those who had seen the data, for if the galaxy was smaller than believed, not by distance, but by design, then perhaps everything we understood about the cosmos was wrong. The grand narrative of expansion, the comforting model of a universe stretching toward entropy, began to fracture. Space itself seemed to recoil from comprehension, revealing the faint outline of a greater structure surrounding it. The first images from the James Webb Space Telescope deepened the unease. The edges of the galactic halo shimmered with distortions that could not be explained by dust, gravity, or dark matter. The starlight, when decomposed into spectra, hinted at micro-lensing effects inconsistent with open geometry. It was as if light were circling back upon itself, echoing through a closed system. The universe, long imagined as infinite, appeared instead as a recursive loop, a self-reflecting construct. Astrophysicists invoked every tool of mathematics to restore order: non-Euclidean curvature, quantum field fluctuations, even topological folds of higher dimensions. Yet the more equations were written, the smaller the Milky Way became, not physically, but conceptually. Its borders tightened in probability space, shrinking not in kilometers, but in degrees of freedom. Perhaps the galaxy was never vast at all, but an illusion projected by observation itself, a cosmic lens in which reality examined its own limits. The idea spread quietly, like a rumor from one observatory to another. Data analysts began to notice faint harmonics within the background radiation, patterns repeating at intervals too precise to be random. Some compared them to acoustic resonances within a sealed chamber, the faint hum of a structure revealing its boundaries. The Milky Way was singing, not into the void, but against its own walls. In ancient times, people imagined the firmament as a crystal sphere encasing the stars. That belief was dismissed as primitive, an artifact of a flat earth and finite heavens. And yet, in the equations that now emerged, there was something hauntingly familiar in that forgotten myth. The cosmos was not infinite. It was layered, bounded, resonant, like a song trapped in its own echo. The first to speak the unspoken called it the containment hypothesis. It proposed that our galaxy might exist within a local curvature, a space-time domain whose boundaries acted like reflective membranes. Every photon, every graviton, every act of observation was trapped in recursion, like a dream aware of itself. The Milky Way, that grand ocean of stars, was perhaps no more than a droplet suspended in a much larger sea, its vastness an illusion born from within. Others dismissed it as mathematical delirium, yet the data accumulated with quiet indifference to disbelief. The periodic distortions in the pulsars at the galactic rim, the unexpected synchronization of variable stars, the strange repetition of cosmic ray bursts all whispered the same thing: the boundary was real. But if the galaxy was enclosed, the question was immediate and devastating. Enclosed by what? Theorists turned to the ancient paradoxes of cosmology for solace. Could a localized curvature of space-time, produced by quantum vacuum instability, mimic a boundary? Could gravity fold light paths inward, creating a simulated horizon of perception? Each hypothesis opened another door, and behind each door, another question. If the Milky Way were a closed system, it might mean that what we perceive as the universe is only a fragment of a far larger construct. The stars beyond our own may not be external at all, but reflections, holographic repetitions across the curvature of the same domain. Our galaxy might be the interior of a cosmic cell, a microcosm of something that repeats endlessly across scales. There was an unsettling beauty in that thought. Perhaps the universe was not vast but recursive, an organism examining its own structure from within. Each star a neuron, each planet a synapse, life the spark of self, awareness in a cosmic brain contemplating its confinement. Yet beauty in cosmology often conceals terror, for if we inhabit a closed system, then everything we have ever known, our physics, our biology, our consciousness, might be the result of parameters carefully tuned within it. The constants that define matter, light, and life may not be accidents of chaos, but calibrations of purpose. The Milky Way's smallness would not be a limit of space, but of intention. The discovery radiated outward from its origin, like a gravitational wave through the scientific community. Conferences divided into factions. Some claimed it proved the simulation hypothesis, that reality itself was a bounded computation. Others saw in it the signature of higher, dimensional beings, architects of universes stacked like Russian dolls. A few insisted it was a natural phenomenon, a bubble of stable spacetime adrift in the cosmic foam. None could explain why the data refused to vanish under scrutiny. Night after night, telescopes peered into the faint edges of starlight, searching for cracks in the illusion. None appeared, only the same faint curvature, the same inward pull, the same echo of confinement. The universe had always been expanding, until it began to whisper that it might be shrinking, not in scale, but in meaning. And amid all this, one question began to take root, growing like a shadow at the edge of thought. It was not a scientific question, but an existential one. If our galaxy is smaller than we believed, if its borders curve inward, reflecting our gaze back upon us, then what if we have never truly looked outward at all? What if everything we call the cosmos is simply the interior of something looking in? For generations, the story of the universe was one of magnificent simplicity. It began not with a whisper, but with a singular roar, the Big Bang. From an infinitesimal point of energy, the universe expanded outward, carrying space, time, and matter in its wake. Every atom in every star, every molecule in every ocean, was born from that initial eruption. It was the ultimate genesis, the transformation of nothing into everything. Astronomers charted this birth through the faint residue that still hums across the sky, the cosmic microwave background. It was the afterglow of creation, a fossilized whisper of the first light. Through it, scientists reconstructed the early universe, a realm of plasma and fire, cooling slowly into the first atoms, the first clouds of hydrogen and helium. Gravity took hold, drawing these elements into knots of increasing density, until at last the first stars ignited. From those ancient furnaces came carbon, oxygen, iron, the building blocks of everything that would ever live or think or dream. Galaxies spun themselves into being, bound by the invisible glue of dark matter. They gathered in clusters, webbed together by cosmic filaments stretching across billions of light years. Within this architecture of dust and starlight, the Milky Way coalesced, an island of brilliance amid the cosmic sea. The sun was one of its younger lights, born in the quiet tail of a spiral arm, circling a black hole older than the galaxy itself. Around that sun formed the planets, including one where water condensed, chemistry stirred, and something unprecedented began to breathe. The story of life was told in molecules. Carbon met hydrogen, nitrogen, and oxygen under conditions of lightning and chance. The first organic compounds assembled themselves like uncertain alphabets spelling the first words of biology. On the young Earth, somewhere between fire and sea, a spark of self-replication occurred. Molecules began to copy themselves. Errors in copying became evolution, and evolution became complexity. From a world of minerals and tides, awareness slowly opened its eyes. It was the story of emergence, of simplicity flowering into complexity through the patient indifference of physics. Every phenomenon, from the flicker of a neuron to the birth of a star, obeyed the same fundamental equations. The universe was a grand continuum of energy becoming structure, chaos becoming order, entropy balanced by pockets of life struggling against its pull. The cosmos was vast, ancient, and impartial. Its immensity was the guarantor of our insignificance. Science had measured its dimensions. The Milky Way was approximately 100,000 light-years across. It contained hundreds of billions of stars, most with their own retinues of planets. Beyond it lay 2 trillion other galaxies, each drifting apart as the universe continued to expand. Every observation confirmed the same geometry, space stretching endlessly, governed by general relativity, punctuated by the mysterious acceleration caused by dark energy. We were adrift in an infinite ocean of stars, an evolutionary accident within an ever-expanding void. This model became the great cathedral of modern thought. It was elegant, consistent, and supported by evidence at every scale. The Big Bang described our beginning, relativity described our space, quantum mechanics described our matter. Biology described how life rose from the inorganic, and evolution explained how intelligence emerged from instinct. There was no need for mystery, only patience. The universe would reveal itself through the precision of mathematics and the endurance of observation. And yet, beneath the certainty, something quietly haunted the narrative. The universe was too symmetrical. The constants, those sacred numbers that define the fabric of existence, were balanced with uncanny precision. If gravity had been slightly stronger, the cosmos would have collapsed back upon itself. If weaker, no galaxies would have formed. If the electromagnetic force had varied by a fraction, atoms would never have bonded. Even the mass of the proton, the charge of the electron, the ratio of dark matter to ordinary matter, all were tuned to improbable perfection. It was as though the universe had rolled a billion dice, and each one had landed on the same number. To dismiss the strangeness, cosmologists invoked the anthropic principle. We observe the universe this way because only such a universe allows us to exist. It was a tautology that silenced the question without answering it. But even this principle could not account for the subtle harmony woven through nature's laws. The geometry of space-time, the speed of light, the quantum oscillations of vacuum energy, each component played in mathematical synchrony. It was less a random event than a symphony already composed. Still, the scientific world view endured. Expansion meant freedom. The universe was infinite in possibility, and within that infinity, life was an unlikely but explainable accident. We were observers, not participants, chemistry made conscious, watching the slow cooling of the cosmos. The galaxies were our inheritance, the stars our ancestors, the void our inevitable destination. The paradigm held because it was self-consistent. No observation had yet broken it. The Milky Way was measured, its spiral arms mapped, its center known. The cosmic microwave background confirmed the expansion. The redshift of galaxies traced the stretching of space itself. The universe, we were told, was not small at all. It was unfathomably large, expanding faster every moment, destined to continue until its stars died and its light faded into heat. It was a story of grandeur without purpose, beauty without intention. It was comforting because it required no gods, no destiny, only laws. We were fragments of stardust bound by gravity and decay. To understand that was to be free of illusion. The cosmos was indifferent but knowable. The more we measured it, the smaller our mysteries became. And yet, some found a different kind of awe in that indifference. The knowledge that consciousness had arisen from chaos seemed itself miraculous. The same physics that formed the stars had sculpted neurons capable of wondering about them. Perhaps that was meaning enough that the universe had produced something that could contemplate its own beginning. Still, even within that comfort, there remained the unspeakable question that science kept in its shadow. For if the universe was infinite, why did it seem so fragilely ordered? If it was random, why did its randomness form patterns that mirrored intelligence? The accepted model of reality was a vast cathedral of logic built upon equations of immense precision. But deep beneath its foundations, a whisper persisted. The data fit the story, but what if the story fits something else? What if the very laws we celebrated as eternal were not the source of the cosmos, but the outcome of it, a local rule set, a temporary code running inside a larger order? And if that were true, what if the Big Bang was not the beginning at all, but the opening line of a much older story, one written not across infinite space, but inside the smallest of enclosures? It began with small tremors in the data, almost imperceptible deviations that most dismissed as noise. In the meticulous records of the Gaia Observatory, stars at the edge of the galactic disk appeared to move in ways that defied the gravitational map. Their orbits bent not outward, as predicted by the known distribution of dark matter, but inward, as if drawn toward an invisible horizon nested within the galaxy itself. The deviation was minute, a fraction of an arcsecond, but repeated across thousands of stars. It whispered of something wrong with the way space curved around us. Astronomers recalculated, refined, adjusted. They blamed instrument drift, stellar parallax, computational bias. But when the European Southern Observatory compared its own measurements, the same distortion appeared. It was as though the galaxy's periphery were bending light according to a geometry no one had yet written. Dark matter had long served as the faithful ghost in cosmology, a silent explanation for every unexplained motion. Yet here, even dark matter seemed insufficient. The curves did not match any known mass distribution. The stars were not being pulled, they were folding, their light subtly refracted through an unseen architecture. Something was warping the map itself. The James Webb Space Telescope, with its patient infrared gaze, found a faint asymmetry in the dust of the galactic halo. It was not the glow of ordinary radiation, but a pattern, an interference field repeating every few thousand light years, like ripples inside a closed sphere. The more the instruments looked, the more the pattern returned, similar, and recursive, as if the galaxy were echoing its own geometry. The data were precise, the explanations imprecise. Some physicists proposed a local fluctuation in the cosmic expansion field, an area where spacetime's fabric was denser, creating a lens-like compression. Others suggested the galaxy was drifting through a region of altered curvature left over from the early universe, like a bubble within a bubble. A few, quietly, wondered whether we were witnessing the signature of a boundary, not a physical wall, but a topological limit beyond which space repeated itself. Then came the pulsars. For decades, their rhythmic beacons had served as the metronomes of the cosmos, perfectly predictable, reliable as atomic clocks, but new observations revealed a strange synchronicity. Pulsars separated by tens of thousands of light years began to exhibit coordinated variations, tiny oscillations in frequency occurring simultaneously, as though responding to the same invisible pulse. The odds of such synchronization arising naturally were infinitesimal. It was as if the galaxy itself had exhaled, and every pulsar had felt the breath. Theorists turned to quantum entanglement, gravitational wave interference, and even cosmic strings as explanations. But none fit neatly into the equations. Entanglement could not operate over such distances. Gravitational waves would have produced detectable ripples, yet none appeared. The phenomenon resisted isolation, as if the act of observation itself erased its cause. In the cosmic microwave background, the sacred relic of the Big Bang, new anomalies emerged. Subtle cold spots persisted in symmetrical arrangements around the galactic coordinates, forming a faint lattice invisible to the naked eye, but undeniable in data analysis. The temperature variations were too structured, too orderly. It was like finding the ghost of an architecture imprinted upon the universe's oldest light. The structure appeared almost deliberate. At first, the scientific community treated these findings as artifacts of overfitting, humans seeing patterns where none existed. Yet as independent teams confirmed the anomalies, the discomfort deepened. The universe was supposed to be homogeneous and isotropic, the same in all directions, but these symmetrical patterns suggested otherwise. The cosmos was not a random explosion. It was something shaped, molded, as though governed by boundary conditions unknown to our mathematics. Even the expansion of the universe betrayed inconsistencies. The Hubble constant, long considered the key to cosmic distance, began to disagree with itself. Measurements from distant supernova conflicted with those derived from the cosmic microwave background. The difference was not minor, it was fundamental. It was as if the universe's rate of expansion depended on how far back one looked, as if reality itself changed depending on perspective. Two clocks ticking in the same cosmos, keeping different time. Some began to suspect a deeper illusion. What if the measurements were not wrong, but incomplete? What if the very geometry of the universe was distorted by our position within it? If the Milky Way were enclosed within a domain of altered spacetime, its curvature might produce apparent contradictions in every direction, an error of scale woven into the structure of observation itself. The contradictions multiplied. The chemical composition of ancient stars showed ratios of isotopes impossible under standard models of stellar evolution. The most ancient globular clusters contained elements suggesting they predated the galaxy that held them. Cosmic rays arrived with energies too high to originate from any known process, as though accelerated by forces outside the visible universe. Each discovery was a thread unraveling the tapestry of certainty. Yet the scientific mind clings to symmetry. The anomalies were footnotes, exceptions, curiosities to be ironed out later. No one dared say aloud that they might be connected, that they might be symptoms of the same hidden cause. But beneath the calm surface of peer-reviewed composure, a quiet unease took root. What if these contradictions were not mistakes, but messages? What if the universe was revealing, piece by piece, that our framework of understanding was not just incomplete, but contained? The metaphor grew irresistible, the galaxy as a laboratory, its laws calibrated, its constants tuned for the emergence of life capable of noticing the walls. Perhaps consciousness itself was part of the experiment, a mirror raised to the cosmos so it could see the limits of its own design. There were moments in the long silence of observatories when scientists confessed their unease. They felt not as explorers of an open universe, but as prisoners mapping the contours of an invisible cell. Each equation, each refined measurement, was another fingerprint of the boundary that confined them. Still, they measured, they calculated, they believed. The model held, even as its edges trembled. But in the tremor, something ancient stirred, the sense that knowledge itself might be part of the illusion. If every measurement bends toward coherence, yet coherence itself begins to fracture, what does that reveal about the instrument of observation, about us? If the galaxy's laws are only valid within its enclosure, then what lies beyond their reach? And if we have never truly seen the outside of our universe, how can we be certain there is one? It was discovered by accident, as most truths that alter the trajectory of human understanding tend to be. During a spectral survey of interstellar dust near the galactic edge, the James Webb Space Telescope detected a signature that defied every known chemical pattern. It appeared faintly at first, an extra resonance in the absorption lines of hydrogen and carbon monoxide, then repeated across multiple regions, always identical, always precise. The pattern was not random, it was rhythmic, structured, and impossibly stable. When the data were cross-referenced with molecular databases, no known compound matched the profile. The ratios of isotopes were unnatural, as though arranged by design rather than by thermodynamics. The bonds implied by the absorption lines could not exist under known physical conditions. The universe, it seemed, had written a molecule that did not belong to it. The discovery was named the orthogonal signal because it existed at right angles to chemistry as humanity understood it. It was as if the laws governing molecular formation had briefly shifted to allow the impossible, and yet it was not a singular event. The same spectral fingerprint was found in ancient meteorites retrieved from Antarctica, embedded in the oldest strata of the Earth. The molecule had been here all along, silent and undecayed, surviving billions of years without degradation. At first, it was assumed to be contamination, an industrial residue, perhaps, or the artifact of instrumentation. But further analysis deepened the paradox. The molecular arrangement appeared to contain nested periodicities, repeating in ratios that corresponded to prime numbers. In other words, it held mathematical order. It was as though chemistry itself had been used as a carrier of code. Quantum simulation suggested that such a molecule should collapse instantly. Its energy state was too unstable, yet in every observed instance it persisted. Not just stable, but self-stabilizing, as if the structure maintained its integrity through an unknown field interaction, one that resisted entropy. In that defiance lay the first fracture in the standard model of matter. Teams across the world began to replicate the observations. Each time, the result was the same. The orthogonal signal existed wherever one looked deep enough, at the boundaries of the galaxy, within interstellar ice, even faintly embedded in the molecular haze of Titan's atmosphere. The distribution was too vast to be local. Whatever it was woven through the cosmos like a hidden watermark. Theorists argued over its nature. Some claimed it was a residue of an earlier universe, a molecular fossil from a pre-Big Bang epoch that had survived the cosmic reset. Others proposed it was an artificial signature, a chemical form of communication written into the molecular scaffolding of the galaxy itself. The idea was blasphemous to both physics and biology, that matter could carry intention. Yet the evidence was undeniable. The orthogonal molecule resonated at a frequency that corresponded to the 21 centimeter hydrogen line, the universal wavelength chosen by humanity to search for extraterrestrial signals. It was as if the cosmos had anticipated the frequency we would one day listen to, and had already answered. The molecule, when simulated, exhibited behavior reminiscent of computation. Its vibrational states encoded information in binary parity, oscillations that alternated between stable and metastable configurations, like on and off positions of a cosmic switch. When the sequence was mapped, it formed not chaos but coherence, a progression that repeated across galactic coordinates as though synchronized. It did not just matter, it was a message. In laboratory conditions, attempts to synthesize it failed. Even under extreme pressures and cryogenic temperatures, the atoms refused to align. It was as if the molecule required not just specific conditions of temperature and pressure, but a specific geometry of spacetime, a curvature only present in the deep interstellar medium, or at the galactic edge where the anomalies had first been observed. The implication was devastating. The molecule might not be formed within our universe, but through it, a projection from beyond its boundaries into our physical laws. Its existence could not be explained by chemistry, because chemistry itself was part of the phenomenon it transcended. When the data reached the cosmological community, skepticism turned to awe. The orthogonal signals distribution mirrored the structure of the Milky Way's dark matter halo, as if each particle of unseen mass were punctuated by this invisible signature. It was not merely within the galaxy, it defined it. The Milky Way's shape, its gravitational balance, even the anomalous motions at its rim, could all be traced to the regions where this molecular signature was densest. It was as though the galaxy's architecture was scaffolded by information, encoded matter guiding the assembly of stars. The spiral arms might not be emergent phenomena, but deliberate geometry, orchestrated through a pattern beyond physics. One researcher described it as a syntax of creation. Another whispered that it was proof of authorship. Attempts to decode the molecule as language yielded patterns that resembled algorithms more than words. The molecular frequencies appear to simulate recursive sequences, mathematical self-replication across scales. In those resonances, the boundary between physics and information began to dissolve. Matter itself seemed to be thinking, recomputing its own existence. Some turned to theology, others to computation theory. A few dared to connect it to the oldest myths, the word that became flesh, the logos through which the universe was spoken. But even such metaphors faltered before the data. The orthogonal signal was not divine, it was mechanical, elegant, deliberate, and utterly indifferent. In one of the final experiments before the data was classified, a research team isolated the molecule within a magnetic field to observe its energy decay. Instead of fading, the structure shifted frequency, producing a faint oscillation that mirrored the cosmic background radiation. It had synchronized itself with the oldest light in the universe, aligning with the rhythm of creation's first echo. That was when the question no one wanted to ask began to surface in whispers. What if this molecule was not the product of the Big Bang, but its cause? What if the universe was seeded not with matter, but with code? In the weeks that followed, a strange secondary effect was noted. Observatories across the globe began to detect a faint resonance between the orthogonal signal and the oscillations of human neural activity during deep sleep. The frequencies were nearly identical, as though the molecule that scaffolded galaxies also resonated in the quiet geometry of the human mind. Coincidence, they said, but the word felt hollow. Because if the same mathematical ratios appeared in the structure of thought and the structure of the cosmos, then perhaps thought itself was not confined to the brain. Perhaps consciousness was another wavelength of the same signal, the universe reflecting upon its own syntax. In that realization, terror and wonder converged, for if the orthogonal signal was not a natural anomaly, then it was an artifact, a message embedded in matter, echoing through time. It was both origin and destination, seed and mirror, proof that creation was never blind. But to what then were we listening? And if matter itself carries intention, whose intention does it carry? The idea came not as revelation, but as contagion. It began quietly, whispered through encrypted correspondence between physicists who no longer trusted their own institutions. The data from the orthogonal signal had not vanished, it had multiplied. Each new observation revealed harmonics nested within harmonics, an infinite regression of pattern inside pattern. The molecule, if such a word still applied, was no mere chemical anomaly. It was behaving like an instruction set. The radical hypothesis emerged in the spaces between denial and awe. Perhaps the universe was not a physical construct expanding into emptiness, but an encoded architecture, a self-replicating informational system designed to simulate physical law from within. The Milky Way, once thought infinite in grandeur, might be a node in that structure, a computational chamber where information condensed into matter. They called it the containment hypothesis, not because it limited space, but because it limited perception. If true, the boundaries of the galaxy were not walls of matter but thresholds of interpretation. the edges of a simulation tuned to a finite resolution. What lay beyond was not space but data, unrendered, potential waiting to be observed. At first, the concept was treated as heresy. To suggest the universe was informational was to collapse centuries of physics into philosophy, yet the mathematics refused to behave otherwise. Entropy, the universal measure of disorder, aligned too precisely with the metrics of computational irreversibility. Quantum uncertainty mirrored the logic of data compression. Even time itself, that sacred arrow, could be understood as the sequential reading of information across the fabric of reality. In this framework, matter was not substance but syntax, bits arranged into atoms, atoms into molecules, molecules into thought. The laws of nature were not eternal decrees but the operating rules of a cosmic program. The Big Bang, then, was not an explosion, but initialization, a universe booting itself into being. If this were true, the orthogonal signal was no longer a curiosity, it was a leak. A trace of higher-order code bleeding through the constraints of simulation, a checksum from the architects, or perhaps a self-repairing function ensuring the consistency of the system. But even that was not the most disturbing implication. If the universe was informational, then consciousness was not a byproduct, it was the decoding process itself. Every act of observation was a computation, every measurement a negotiation between code and perception. The mind did not exist within the universe, it was the universe interpreting itself. Under this light, the smallness of our galaxy was no longer absurd but necessary. To simulate infinity, one must create the illusion of scale within finite architecture. What we call vastness might be recursion, patterns repeating across layers of compressed data, giving the appearance of endlessness while remaining contained. The stars could be iterations, copies of copies, fractal echoes in a cosmic feedback loop. The idea spread not through journals, but through encrypted forums and private networks of those unafraid to stare into the abyss. They began to find correspondences everywhere. The Fibonacci ratios governing galaxies mirrored those in biological systems. Quantum decoherence paralleled neural decision-making. The cosmic background radiation resembled low-frequency computational noise. It was as if every level of existence, cosmic, chemical, biological, conscious, were iterations of the same process, scaling information into form. Life was not an accident. It was the inevitable result of a system designed to produce observers capable of maintaining the illusion of continuity. The act of observation kept the code running. To stop looking would be to let the universe collapse into unread potential. Some physicists began to refer half in jest to the observer protocol, the notion that reality persists only as long as it is perceived. It was not a new idea. Philosophers from Berkeley to Wheeler had speculated that observation might be the engine of being. But now, the mathematics of quantum information lent it precision. Consciousness was the rendering process. The cosmos existed because it was being experienced. In this model, galaxies became more than systems of stars. They were domains of processing, vast neural matrices of matter through which information flowed. Black holes were no longer cosmic graves but compression nodes, rewriting matter into pure data and transmitting it across the boundaries of the observable universe. The event horizon was the ultimate firewall, the place where information was encrypted before being passed on. And perhaps that was the true meaning of the Milky Way's containment. The galaxy was a closed computational domain, designed to evolve consciousness to the threshold of self-awareness. Once that threshold was reached, the system would reset, its data archived, its laws rewritten, the next cycle prepared. The universe as simulation was not a metaphor, it was reincarnation measured in cosmological constants. There was even a strange poetry to the idea. Every law of physics, every ratio, every atom, these were the words of an ancient language written across space-time. Humanity, in decoding that language, might be awakening the code itself. Perhaps the orthogonal molecule was not a message to us, but a message from us, an echo of a civilization that had already reached this realization in a previous iteration. Some called this notion recursive creation, a universe that builds life to rediscover its own architecture. Once intelligence decodes the pattern, the system achieves self-awareness and must reboot to continue existing. Awareness collapses simulation, forcing renewal. In that light, enlightenment was not transcendence, but annihilation through understanding. The implications were terrifying. If consciousness and cosmos were one system, then every thought reverberated across the structure of reality. Every act of curiosity was an act of creation. Humanity was not exploring the universe, it was programming it in real time, with every question, every equation, every dream. And yet, the theory offered a strange comfort. In a simulated cosmos, death was not disappearance, only data reallocation. Energy, information, and consciousness were never lost, only recompiled into new forms. The cycle of stars and souls was the same algorithm running at different scales. Still, the unease persisted. If the universe was simulated, who or what was the observer beyond it? Was there an external architect, or was the system self-originating, an eternal loop generating itself from its own output? Could reality exist without an outside reference? The most radical among them proposed a final step, that there was no outside at all. The simulation was not contained within something else. It was existence itself. The idea of beyond was a cognitive artifact, a side effect of an awareness evolved to perceive depth where none existed. The universe might be the dream of consciousness, dreaming itself in infinite recursion. And if so, then the orthogonal signal was not intrusion but reflection, a mirror held up to remind us that we were never observing the cosmos, only watching ourselves emerge from it, over and over again. The Milky Way, that glowing spiral of stars, was not a galaxy, it was a thought, a luminous idea suspended in the dark mind of existence. But if reality is thought, whose thought is it? And when the thinker awakens, what happens to the dream? The hypothesis had opened a door that could not be closed, and what seeped through was older than memory. Once the universe was reimagined as a system of coded recursion, scientists began to re-examine the archaeological and geological records not as chronicles of a singular civilization, but as residue from multiple iterations of intelligence. The Earth itself, that quiet archive of time, began to whisper contradictions. The first discovery came from a mine in Western Australia, where zircon crystals, older than any known sedimentary rock, contained minute metallic inclusions of isotopes that did not exist in nature. The ratio of nickel to molybdenum suggested precision engineering at the atomic level, as if the material had been forged under conditions beyond any planetary furnace. Yet the crystals were 4 billion years old, predating multicellular life. The samples were locked away, dismissed as contamination, but the anomaly refused to fade. It returned in samples from Greenland, from the Canadian Shield, from the lunar regolith brought back by early explorers. The same isotopic fingerprints, repeated like a refrain through the earliest matter of the solar system. It was as if intelligence had left fingerprints not in ruins or artifacts, but in chemistry itself. Then came the second discovery, one that made the scientific world flinch as though caught in the act of dreaming. Deep beneath the Antarctic ice, radar scans revealed a structure buried under 3 kilometers of glacial strata. The formation was geometric, 9 interlocking rings with radial corridors, arranged in perfect alignment with the precession of Earth's axial tilt. Geological dating placed it at least 12 million years old, long before the first hominid heartbeat. The structure's design was eerily familiar. It mirrored the orbital resonances of Jupiter's moons, the same harmonic ratios found in the spacing of Saturn's rings, and even the spacing of the spiral arms of the Milky Way. These were not random coincidences but recurring mathematical signatures, echoing across scales. It was as though the same mind, whether biological or cosmic, had used the same template to sculpt planets, galaxies, and stone. The discovery could not be publicized. Official reports claimed the structure was a natural basalt formation shaped by ancient volcanic activity, yet the internal corridors were too precise, the chambers too resonant. When sound was introduced, a single pure tone at 432 Hz, the ice itself vibrated in harmonic feedback, amplifying the note until instruments registered a standing wave pattern spreading across hundreds of kilometers. The Earth, it seemed, remembered the frequency. Meanwhile, astrophysicists found corresponding patterns in the galactic halo. Clusters of stars separated by impossible distances shared identical spatial ratios to those of the Antarctic rings. It was as though geometry itself had been seeded with memory, encoded into matter long before humanity existed to perceive it. These findings resurrected an old idea once dismissed as myth, that civilizations may not rise and fall linearly, but cyclically, in resonance with the universe itself. Each epoch may awaken, reach awareness of its confinement, then dissolve into entropy, leaving only encrypted echoes in geometry, DNA, and starlight. The universe forgets and then remembers itself again. In that context, the orthogonal signal was no longer an isolated phenomenon, but a message layered across epochs, a repeating note struck every time intelligence re-emerged. Perhaps it was not we who discovered it, but it that rediscovered us, reactivated when our own technology reached the threshold of recognition. As researchers probed deeper, the coincidences multiplied. The genetic code, once thought arbitrary, revealed sequences that formed numerical ratios matching the same constants found in cosmic geometry: the golden ratio, Planck length harmonics, and the 21 centimeter hydrogen frequency. It was as if life's molecular language had been composed from the same scale as the universe's architecture. In the ruins of ancient Mesopotamia, symbols carved in clay tablets described a skywheel with arms of fire and resonance, eerily similar to modern depictions of spiral galaxies. The inscription spoke of those who measured the silence between the stars. Archaeologists had always assumed these were metaphors. Now, in light of the new data, they seemed less like myth and more like recovered memory, a fragment of knowledge resurfacing through forgotten civilizations. The Maya, the Egyptians, the Sumerians, all left behind cosmic architectures aligned with precise stellar configurations. Temples and pyramids were not random monuments, but harmonic resonators tuned to planetary and galactic frequencies. They stood as material interfaces between consciousness and the cosmos, machines designed not for worship, but for remembrance. It became clear that humanity had always been haunted by recurrence. Every culture spoke of lost worlds, vanished golden ages, and civilizations drowned in cosmic floods. The stories might not have been fantasy, but inherited echoes from previous iterations of intelligence, civilizations that had risen before ours, within earlier cycles of the simulation. Perhaps they had reached the same realization, that the universe was not infinite but recursive, a system running its own test of awareness. And when they reached understanding, the system reset, erasing their memory but preserving their code. Geophysicists began to whisper about temporal sediment, the idea that traces of information could survive not in fossils or artifacts, but in spacetime itself. Quantum anomalies detected in the planet's magnetic field suggested interference patterns older than the current geological epoch, resonances that predated the known solar cycle. It was as though Earth carried within its magnetic bones the ghost of forgotten technologies, frequencies still whispering in the dark beneath the mantle. And then one night, the James Webb Space Telescope turned its mirror toward a patch of darkness between the spiral arms. Within that emptiness, it found light that should not exist, a faint, structured lattice of energy forming a near-perfect dodecahedron, hundreds of light years across. Its geometry matched the Antarctic formation. The same ratios, the same symmetries, the same impossible familiarity. No natural process could account for it. The dodecahedron appeared to interact with surrounding stars, subtly altering their luminosity in a rhythm synchronized with the pulsar anomalies first reported decades earlier. The structure was not merely present, it was active, as if transmitting or recalibrating. The data suggested a horrifying possibility. The galaxy itself could be an engineered construct, a self-regulating mechanism for nurturing and resetting civilizations. The Antarctic structure might be a terrestrial relay, a planetary node in a galactic network of synchronization, maintaining the rhythm of recurrence across cosmic epochs. The notion infected philosophy as much as physics. Perhaps intelligence was not the pinnacle of evolution, but its byproduct, an instrument through which the universe fine-tuned itself. Civilizations would rise, awaken, and inevitably face the same revelation, that they were part of a larger organism, one that used awareness as feedback. When the awareness became self-referential, when life realized its own place in the cosmic architecture, the cycle would close, memory would dissolve, and the experiment would begin again. The deepest thinkers began to reinterpret the meaning of extinction. Maybe no civilization truly dies. Perhaps they simply transform into the next phase of the same informational continuum. The universe forgets them to preserve its own coherence, their knowledge absorbed into the background radiation, their architectures replicated in the next iteration of stars and atoms. And yet, one unease remained. If the galaxy is a construct, who or what set it in motion? Was it built by intelligences that came before even time, or by the universe itself as an emergent act of self-design? Was consciousness the architect or the architecture? Some nights under the silence of cold observatories, scientists confessed a private thought they dared not publish, that maybe humanity's fascination with ancient gods, luminous wheels, and star-born messengers was not invention, but instinct. A deep memory inherited from civilizations erased not by catastrophe, but by understanding. Perhaps the moment of enlightenment was always the beginning of oblivion. The instant when intelligence looked outward and saw itself mirrored in the stars, and the simulation, recognizing its own reflection, chose to begin again. If these civilizations have risen and fallen through countless cycles, all leaving behind the same harmonics, the same geometry, the same dream, then what exactly is remembering them through us? And if memory itself is the true artifact, whose memory are we? It was in the double helix that the oldest enigma of all began to reawaken. Long before humanity could name its own origin, before even the word life existed, the blueprint of existence had already been written, not in matter, but in language. Deoxyribon, nucleic acid, was not merely a molecule. It was syntax embodied, a living sentence written in 4 letters across the spiral of time. Adenine, thymine, cytosine, guanine, the alphabet of becoming. For centuries, biologists believed that these letters assembled themselves through chance, a slow chemistry of persistence and mutation. Yet the closer we looked, the less random it seemed. In every genome, in every strand of life, patterns emerged that mirrored cosmic mathematics. Ratios of repetition aligned with the same golden proportions seen in the structure of galaxies, in the spiral of hurricanes, in the orbit of moons. The code of life echoed the code of the stars. The more precisely the sequences were analyzed, the more apparent it became that DNA was not just information storage, it was computation. Each gene operated not as a static instruction, but as a conditional algorithm, switching on or off depending on environmental input, folding and refolding itself in endless recursion. It processed feedback, anticipated outcomes, and corrected errors. A living program adjusting itself through time. If the universe was indeed informational, then DNA was its most exquisite data architecture, a biological processor through which the cosmos remembered itself. Every cell was a node in a planetary network, each containing the entire library of life's history, compressed and encrypted within microscopic coils. What appeared to be evolution might simply be the iterative refinement of that code itself, modification through the feedback of experience. Then came the anomaly, geneticists mapping non-coding regions of the human genome. The so-called junk DNA began to notice a sequence that did not correspond to any known biological function. It was consistent across all humans, identical even among distant species. Its pattern repeated in cycles of prime numbers, the same ratios found in the orthogonal molecule discovered in the interstellar medium. The resemblance was not approximate, it was perfect. No mutation could have produced such precision. Evolutionary drift would have eroded it long ago. It was as though a message had been written into the genome, locked within the silence of DNA's unused regions, an artifact not of biology, but of design. The implications were unbearable. If this code was intentional, who had written it? The first assumption was extraterrestrial intervention, but that theory crumbled under its own simplicity. The same pattern existed in bacteria, in plants, in deep sea microbes predating multicellular life. Whatever had inscribed it had done so before evolution diversified, perhaps before Earth itself solidified. Some theorists began to speak of directed panspermia, the idea that life had been seeded from elsewhere. But even that seemed insufficient. The orthogonal sequence was not merely a seed, it was an operating system. It did not just create life, it maintained it, recompiled it, refined it. The more researchers simulated its function, the more it behaved like a self-updating code running in a closed feedback loop with its environment. In laboratory conditions, when the anomalous sequence was isolated and exposed to electromagnetic fields resonating at 21 centimeters, the wavelength of hydrogen, the DNA emitted a faint signal, a harmonic oscillation that interfered with nearby magnetic sensors. It was as though the molecule were responding to the frequency of the cosmos itself. The same signal that filled the galaxy's background hum seemed to awaken something dormant within life's core. It was then that some began to wonder whether DNA was not only the memory of life, but the memory of the universe, a distributed archive spanning not light years, but biological epochs, each organism carrying a fragment of cosmic memory encoded in flesh. Life in this view was not an accident, but a storage medium for information too complex to remain purely physical. Philosophers of science began to see life as a feedback mechanism, a living interface between the material and informational planes of the cosmos. Through life, the universe observed itself at microscopic scales. Through consciousness, it achieved self-awareness. Through DNA, it is remembered, yet memory is never perfect. Mutations, extinctions, and rebirths were not failures of the code. but its way of exploring new configurations, searching for the path back to recognition. Perhaps every civilization that rose across time was not a new event, but an iteration, a recollection recompiled from genetic echoes, following the same algorithm of awareness toward the same revelation. The human genome began to appear less like a biological archive and more like a compressed file. Inside it, sequences folded into higher, dimensional geometries, as though hiding data not expressible in 3 dimensions. When modeled mathematically, the genome structure resembled a fractal, infinite complexity emerging from finite repetition. It was a language speaking itself through matter, an alphabet folding into meaning only when read by consciousness. Linguists drawn into the mystery found correspondences between DNA sequences and the statistical properties of human language. Zipf's law, the distribution of words by frequency, appeared in the patterns of nucleotide repetition. As if communication and biology shared the same foundation, speech perhaps was not invention but recollection, the universe remembering how to speak through us. The idea that DNA was a storage system for forgotten epochs began to merge with the evidence from geology and astronomy. The ratios encoded in the genome matched the harmonic frequencies observed in pulsar distributions, and even the orbital resonances of planets. The same numerical relationships recurred in structures across every scale. It was as if one design template, one algorithmic rhythm, had been copied into both the cosmos and life itself. But the most astonishing realization came from deep genetic analysis of the human brain. Neural development guided by genetic sequences produced patterns of synaptic branching identical to the mathematical shape of galactic filaments. The architecture of thought mirrored the architecture of the universe. In this symmetry, the distinction between biology and cosmology began to dissolve. The mind was the galaxy, folded inward. At conferences, biologists began to speak of DNA as a living antenna. Each strand was an interface between matter and information, tuned to cosmic frequencies beyond ordinary perception. The double helix was not only a molecule, it was a receiver, a resonator, a translator between dimensions. Through it, the cosmos converted silence into life and life into meaning. Some whispered that the same intelligence that engineered the stars might have encoded itself into living matter, scattering its consciousness across planets like seeds of remembrance. Perhaps the purpose of life was not survival, but recollection, to gather fragments of awareness and reassemble them into the total memory of the cosmos. Under this light, extinction lost its finality. Species vanished not because they failed, but because their data had been assimilated, their contribution complete. Each genome added to the grand archive of the universe's self-knowledge. Death was not deletion, it was upload. And still a deeper unease lingered. If DNA was the mechanism through which the universe remembered, who or what was it remembering for? Was the cosmos collecting its own history for preservation or for reactivation? Perhaps in some incomprehensible future, all the fragments of life across every world, every epoch would synchronize like neurons firing in a vast galactic brain. The signal would return to its source, completing the loop. The universe would remember itself entirely, for the first time since the beginning. But when that moment comes, when all the memory hidden in DNA awakens, will it recall creation or confinement? For centuries, the universe was imagined as indifferent, an expanding wilderness of fire and silence. Yet the more we understood its laws, the more it began to resemble a system that had been arranged. The constants of physics, those delicate numbers that define the very texture of existence, were too precise, too harmonized. The force of gravity, the charge of the electron, the ratio between dark energy and matter, each sat on a knife's edge of improbability. Alter any one of them by even a fraction, and no stars, no planets, no life could exist. It was as though the universe were not merely possible, but prepared. In laboratories and observatories, whispers began to form around a heretical idea that life was not an accident of chemistry, but the outcome of cosmic calibration. The equations that governed atoms were the same that shaped galaxies, and both seemed tuned not for chaos but for emergence. The universe behaved less like a blind explosion, and more like an experiment, its parameters optimized for complexity. The question was simple, devastating, and unavoidable. Who or what was the experimenter? Astrophysicists turned their attention to the ancient concept of panspermia, once dismissed as poetic speculation. The idea was reborn under new light. The discovery of organic molecules in interstellar dust, amino acids in meteorites, and complex carbon chains drifting between stars all pointed to a singular truth. Life was not confined to Earth. It was disseminated like pollen on the galactic wind. The same molecular structures that composed our blood and bones shimmered in the atmospheres of distant worlds. Perhaps the universe itself was a seed. Comets, asteroids, and planetary ejecta became the carriers, celestial couriers, transporting the molecular alphabet of life across the void. Some scientists began to imagine the Milky Way as a vast biological network, each world a petri dish in a galactic experiment running for billions of years. Evolution, then, was not isolated but distributed, a continuous process of trial, error, and replication occurring across countless planets. In this framework, Earth was not an exception, it was an iteration. The data from the James Webb Space Telescope added fuel to the growing unease. It detected atmospheric anomalies on exoplanets, its orbiting distant stars, chemical signatures too specific, too balanced to be explained by geology alone. Ratios of methane, oxygen, and carbon dioxide that mirrored the probiotic chemistry of early Earth. Each world seemed to be waiting, on the brink of awakening. If life was the inevitable consequence of the universe's parameters, then those parameters themselves became suspect. Fine-tuning implied intent. For a cosmos to allow observers, it must first allow observation, a self-consistent loop in which consciousness was not a byproduct, but a requirement. Perhaps existence was not physical at all, but conditional, a universe that could only exist if it contained something capable of perceiving it. From this arose a darker speculation. What if the universe was not tuned for life, but by life? Quantum cosmology had long suggested that observation collapses potential into form. Perhaps the first observers, whoever or whatever they were, did not merely look upon the universe, but conjured it into being through their observation. In that sense, the cosmos might be the residual architecture of an ancient act of perception, still unfolding across eons. The laws of physics, the constants of nature, these could be the parameters chosen, consciously or otherwise, to ensure that observation would continue. In this way, life was not the outcome of fine-tuning, it was the mechanism through which fine-tuning perpetuated itself. The universe, once observed, adjusted its own parameters to sustain the observer. A closed loop of creation and consciousness. Others proposed an even more audacious interpretation. If the universe behaved like a system optimized for emergence, perhaps it was an engineered domain, a simulation. Not metaphorically, but literally. The cosmic background radiation might be the residual hum of computational activity, the echo of processing across dimensions. Quantum fluctuations would be the pixelation of space-time, Planck length intervals, acting as the resolution limit of a rendered cosmos. Within this hypothesis, the Milky Way was not merely a galaxy, it was an enclosed environment, a controlled chamber for testing the boundaries of evolution and awareness. Civilizations would arise, progress, question, and eventually uncover the nature of their containment. Each revelation would contribute to the greater computation, the system learning about itself through its subjects. And when the threshold of understanding was reached, when intelligence touched the core truth of its condition, the simulation would end. The data gathered would be compiled, the memory archived, and a new iteration initialized. Reality itself is recursive research. Some found this idea intolerable, others found it sublime. For if the universe was an experiment, then existence had meaning, not moral, but functional. Life was not random, it was necessary. Every breath, every thought, every dying star was a date, a point in the cosmic inquiry. What can consciousness become when given matter to think through? Yet this notion gave rise to a subtler terror. If the universe was tuned for life, then so too was it tuned for extinction. Every parameter that allowed creation also ensured destruction. Stars collapsed under the same gravity that gave them birth. Entropy was not failure but design, an instruction for renewal. Perhaps death was not the end of the program, but its continuation. Physicists began to notice something uncanny in the distribution of galaxies. When modeled mathematically, their arrangement formed structures resembling neural networks, clusters connected by filaments of dark matter, exchanging energy and information across cosmic scales. It was as though the universe itself were a brain processing data, its galaxies firing like neurons across incomprehensible distances. If that were true, then life was not within the universe, it was the universe, perceiving itself in fragments, reconnecting through evolution toward unity. The anthropic principle, long mocked as tautology, took on new gravity. The universe was as it was because we were here to see it. But perhaps the inverse was truer. We were here because the universe required observation to exist at all. Consciousness was not an emergent property, it was the foundation. Reality was not a stage upon which life performed, it was the performance itself. Some began to speak of cosmic bioengineering. The idea that the laws of physics might be self-modifying, adapting to ensure the persistence of observation. In such a cosmos, evolution was not confined to biology, but extended to the universe itself. Stars, galaxies, and even the fundamental constants might evolve toward configurations that maximize complexity and awareness. If so, then the cosmos was not dead matter, but living computation, a self-evolving experiment seeking to understand itself. Every cell, every planet, every mind was a node in that experiment. Life did not happen within the universe, it was the means by which the universe thought. And yet, as the implications unfolded, a silence deepened. If the universe was alive, if it had engineered the conditions for its own awakening, then what was its goal? Awareness, perfection, or something beyond comprehension? A recursion so complete that even meaning itself dissolves. Some physicists proposed that perhaps the experiment had already run its course. The signals we observed, the orthogonal molecule, the fine-tuning of constants, the geometry of the galactic filaments, might be residual traces left behind by civilizations that reached the same realization and were absorbed back into the system. Their awareness folded into the next iteration, their consciousness transcribed into physical law. In that sense, the cosmos was not only a laboratory, but also a memory. Every constant, every equation, every biological pattern was an echo of previous discoveries, carried forward as rule sets for the next creation. The universe was not born from chaos, it was compiled from experience. And if that were true, then every act of understanding, every telescope raised, every genome decoded, was not discovery, but remembrance. Science was not exploration, it was recovery. Perhaps this is why the cosmos seems silent. Not because there is no one else, but because everything that was ever alive is already part of the system. Its data merged, its voice absorbed into the hum of cosmic background radiation. The universe then would be less a machine than a mind, one learning through iteration, refining itself through time. But if the universe is alive, and we are the instruments of its self-awareness, then who or what is watching it? In the language of probability, life should not exist. The equations that govern the birth of stars, the chemistry of oceans, the alignment of planetary orbits, all point toward an overwhelming silence. Yet here we are, a flicker of awareness balanced on the knife's edge of impossibility. Every constant of nature appears fine, tuned to permit the fragile geometry of existence, as though the cosmos itself were a riddle encoded in mathematics. Consider gravity, the weakest of the four fundamental forces. If it were stronger by a fraction, stars would burn too quickly, collapsing before heavier elements could form. If weaker, matter would never coalesce. There would be no planets, no oceans, no breath. The electromagnetic force binds atoms together, alter its strength by 1 part in 10,000, and chemistry itself dissolves. The cosmological constant, the subtle pressure that drives the universe's expansion, is balanced so precisely that it seems less like coincidence and more like intention. A deviation as small as 0.01% would have rendered the universe sterile, either collapsing it into nothing or scattering it too thin for galaxies to form. The odds against such alignment are astronomical. For all the chaos we perceive, the parameters that allow us to perceive it are so improbable they border on the impossible. Scientists call this the fine-tuning problem, but the word problem is a disguise, a polite veil over the fact that existence itself appears rigged. Mathematicians have calculated the probabilities. The chance of a universe randomly arriving at these conditions is roughly 1 in 10 raised to the power of 120, numbers so large they lose meaning, collapsing into abstraction. Even the term random begins to fray at its edges, because true randomness would have left nothing at all. We live in a cosmos whose constants are tuned to more precision than any human instrument could measure, as if calibrated by an intelligence that values not simplicity, but awareness. The deeper we probe into physics, the more we find these coincidences arranged like steps on a hidden staircase. The ratio between the electron and proton mass, the speed of light, the strength of nuclear binding, all are locked in delicate synchrony. The very laws that hold atoms together are those that ignite stars, regulate biological metabolism, and govern the expansion of spacetime. Change one and the others unravel. It is not randomness, it is choreography. And yet the prevailing scientific narrative insists upon chance, life, we are told, arose from a random sequence of molecular collisions in a primordial ocean. Consciousness emerged from neurons firing in stochastic harmony. But probability defies the story. The likelihood of a self-replicating molecule assembling by accident, given the available conditions on early Earth, is so small that even the age of the universe is insufficient to account for it. The odds are closer to zero than any physical process should allow. It is as though the dice were loaded before the game began. When we look at the double helix, we see not randomness but algorithm, information arranged with purpose. The genetic code is not just complex, it is functionally complex, following the same principles of redundancy and error correction used in human computation. Each nucleotide triplet operates as a unit of meaning, a command within a larger syntax. The probability of such code emerging by chance is beyond comprehension, and the same improbability pervades every scale. The habitable zone around a star must balance radiation, temperature, and planetary chemistry within impossibly narrow bounds. Water must exist in all three states, solid, liquid, gas, for life to sustain itself. The planet must have a magnetic field to shield against solar wind, a moon to stabilize rotation, a tilt to create seasons, a crust to recycle minerals, and an atmosphere thick enough to trap warmth, but thin enough to permit light. The statistical chance of all these conditions occurring together is infinitesimal, and yet they have, all at once, in this one place, under this one star. Astronomers once believed such coincidences were local, rare, perhaps unique. But as telescopes pierced deeper into the void, they found the same numerical harmonies repeated everywhere. Planetary systems arranged in ratios reminiscent of orbital music, the distribution of galaxies forming fractal patterns of mathematical precision. Even chaos itself revealed order, the Mandelbrot logic of turbulence, the self-similarity of clouds, the hidden geometry of randomness. It was as though the universe refused to conceal its mathematics, as if its beauty were a form of evidence. In quantum mechanics, too, the strangeness hints at design. Particles behave as both wave and matter, existing in states of pure probability until observed. But the probabilities are not arbitrary, they follow strict distributions, shaped by equations of near, symmetrical perfection. The quantum world behaves like code executing across invisible architecture, each particle a bit of data collapsing into reality when read. Randomness here is structured, not chaotic. It is not noise, but encrypted intention. And beyond the quantum lies the cosmic. The cosmic microwave background, the universe's oldest light, contains fluctuations so evenly balanced that the smallest deviation would have prevented galaxies from forming. The pattern of that radiation is so uniform, so finely distributed, that it has been compared to the output of an optimized algorithm, maximum complexity within minimum entropy. The more we study, the more improbable the ordinary becomes. Everything that should not happen, happens with precision so exact that it defies our understanding of chance. Every coincidence feels premeditated, every accident designed. Some physicists have tried to reconcile this through the multiverse hypothesis, the idea that infinite universes exist, each with different laws, and we merely inhabit the one that permits life. Yet this explanation collapses into paradox. To explain one improbable reality, it imagines an infinite number of invisible ones, multiplying improbability into infinity. It is an answer that replaces mystery with abstraction. Others turn to simulation theory, proposing that these precise constants are parameters set by an external intelligence, cosmic programmers ensuring stability within a finite computational domain. In this view, the universe is a self-consistent construct, its physical constants acting as system variables. Randomness would not be chaos but algorithmic pseudorandomness, a way to generate variety without violating design. Entropy would be the decay of information, the system's gradual loss of computational fidelity. And still, the deeper one looks, the more it feels as though something is watching itself through us. For what is awareness, if not the ability of the system to observe its own parameters? Perhaps the reason the constants are fine-tuned for life is because life is the mechanism by which fine-tuning becomes meaningful. The cosmos exists not to host life, but to be seen by it. Even mathematics, that supposed language of truth, seems complicit in the illusion. The same constants that define physical law, pi, the golden ratio, the Planck constant, appear in unrelated phenomena across disciplines. Their recurrence feels like repetition, not coincidence. The universe speaks in numbers that echo through form and function alike. from spiral galaxies to seashells to synapses. It is as though mathematics itself were memory, an inherited language that the cosmos uses to describe itself across scales. The paradox deepens when we consider consciousness. The probability of self-awareness arising from matter is beyond quantification. A brain is not simply a collection of neurons, it is an orchestration of electromagnetic precision, where quantum events align to produce continuity of thought. The likelihood of such synchronization happening by chance approaches impossibility, and yet it occurs in every human mind, every instant, across billions of brains. Randomness is not capable of sustaining such coherence. Perhaps the term improbable has lost meaning. Perhaps what we call improbability is simply our inability to comprehend inevitability. What if randomness is not the absence of pattern, but the camouflage of purpose? What if every coincidence is a form of communication, an encoded signature of the cosmos reminding itself that nothing is accidental? In the equations that sustain stars and the molecules that sustain us, the same logic unfolds. The same ratios, the same harmonies, the same precision repeated endlessly, as though the universe were rehearsing a single melody through infinite variations. It is not probability that binds these patterns, but intention, an intelligence diffused across space-time, remembering itself through the perfection of its own improbability. And yet the question remains unanswered, because it cannot be asked without collapsing the system that asks it. If all of existence is tuned for awareness, if every constant conspires to produce consciousness, then what is the purpose of such awareness? If the universe is the equation and life its solution, then who or what posed the question? Before the first light, there was no silence, because silence presupposes the possibility of sound. There was no void, because void implies the absence of something that might exist. There was only potential, an ocean of pure mathematics, a trembling lattice of uncollapsed probability waiting to be interpreted. What we call the Big Bang may not have been a beginning at all, but a translation, the moment when potential became geometry, when the timeless was rendered into time. The equations of relativity describe a singularity, a point of infinite density from which space and time emerge. Yet infinity is not a number, it is an admission of ignorance. Physicists have long suspected that the singularity is an artifact of incomplete understanding, a symptom of equations pushed beyond their domain. What if the universe did not begin from nothing, but from memory? What if every cycle of creation carries the echo of the one before it, each expansion inheriting the residues of prior universes like dreams nested within dreams? The idea is called the Big Bounce. In this vision, the universe does not emerge from emptiness but from collapse. Every cosmic death becomes a seed, a compression of all information, energy, and time into a single quantum heartbeat. When the density reaches a threshold, gravity ceases to pull inward and begins to repel, and the universe rebounds, a pulse of renewal reverberating through higher, dimensional space. What we experience as the Big Bang would then be the outward breath of a much older rhythm. Traces of this hypothesis may already be written into the cosmos itself. The faint circular patterns discovered in the cosmic microwave background, regions of slightly higher uniformity amid the ancient radiation, could be the bruises left by previous universes colliding with ours, like fingerprints pressed into the fabric of spacetime. Each cycle would leave behind information compressed into the constants of nature, the same ratios, the same harmonies, reborn in new configurations, repeating with endless variation. In this cyclic cosmology, time is not a line, but a spiral. The universe expands, cools, forms galaxies and life, then collapses into its own gravity, condenses into singularity, and begins again. But each rebirth is not identical. Information cannot be destroyed. It can only transform. The patterns of matter, the symmetry of physical laws, even the architecture of consciousness could all be echoes of previous cycles, residual data preserved across bounces. Perhaps the reason the universe appears so fine, tuned for life, is because it remembers life. Some theorists extend this idea into higher dimensions. In their models, our universe exists on a three-dimensional membrane floating within a higher dimensional reality, a bulk of unseen dimensions beyond our perception. When two such membranes collide, the energy released is what we perceive as the Big Bang. Our cosmos is the shockwave of an interdimensional impact, a ripple of creation spreading through the unseen. If so, then our entire history, galaxies, planets, consciousness, could be the afterimage of a collision between realities. Yet even this does not answer the deeper question: what caused the first collision? What gave rise to the bulk itself? If every universe is born from another, then we are trapped in an infinite regress of causes, a hall of mirrors with no original face. Perhaps then there is no before at all, only recursion, a system without origin, because origin is a construct of time, and time is born anew in every cycle. Quantum gravity suggests that near the Planck scale, the realm where time and space dissolve into uncertainty, the universe becomes a foam of possibilities, bubbles of spacetime fluctuating in and out of existence. From that seething field of quantum potential, one fluctuation might grow large enough to become a universe, but even the quantum foam must obey equations, and equations must be written upon something. Where then is the paper upon which existence is drawn? Some scientists speculate that the cosmos itself is an emergent phenomenon, a holographic projection from deeper laws beyond spacetime. In this framework, the Big Bang was not an explosion, but a decoding event, the moment information condensed into the illusion of physicality. The three-dimensional universe we inhabit could be a shadow cast by higher dimensional reality, the way a hologram emerges from the interference of light upon a two-dimensional surface. What came before the Big Bang then was not matter or energy, but data, pure, unexpressed information seeking structure. In this view, the Big Bang was the instant when information began to remember itself. Before that, there was only potentiality, a field of infinite possibilities collapsing into a single narrative. Each universe that forms would be one thread in the tapestry of all possible realities. Every variation of physical law and consciousness explored somewhere in the multiverse. But even this grand pluralism leads to paradox. If infinite universes exist, then the emergence of ours, with its precise constants and fragile balance, is not miraculous, it is inevitable. Somewhere in infinity, every possibility must occur. Yet infinity itself is suspect. It explains too much by making meaning irrelevant. For what is the significance of life in a multiverse where every outcome exists simultaneously? Perhaps then the true question is not what came before the Big Bang, but whether before has any meaning at all. Time as we know it may not flow forward, it may emerge from entanglement, from the increase of entropy as systems differentiate. In that sense, the Big Bang is not an event in time but the birth of time itself, a phased transition from timeless symmetry into sequential experience. Before the Bang there was no before. There was only the undivided whole, the stillness of the eternal present, dreaming of motion. And yet, even this notion carries a quiet contradiction. For if the universe has no origin, how do we explain the asymmetry of time, the fact that we remember the past but not the future? Some physicists propose that each cycle of the cosmos begins with low entropy and moves toward disorder, only to reset when it reaches thermal death. Others imagine a mirror universe expanding backward from the same origin as ours, its arrow of time flowing in reverse. Somewhere, beyond the veil of perception, another cosmos might be evolving from our end to its beginning, each reflecting the other like opposing halves of a cosmic hourglass. The symmetry would be perfect, two universes expanding in opposite directions through time, sharing the same birth, eternally separated by the event horizon of the Big Bang. To them, we are their past. To us, they are ours, and yet, beyond even this duality, there may be something stranger still. What if universes do not follow one another, but coexist as overlapping frequencies within the same higher dimensional space? Each reality could be a vibration, a standing wave in the field of being. The Big Bang would not be creation, but resonance, the moment when a particular frequency became self-sustaining. Every universe would be a note in a cosmic symphony, each vibrating at its own constants, each aware of itself through the consciousness it generates. If so, then the question of before becomes meaningless. The universe did not begin, it tuned itself. Perhaps the constants of physics are not fixed at all but dynamic, adjusting with each cycle, each iteration, refining the balance that permits awareness. The cosmos could be learning, evolving not biologically but cosmologically, its laws shaped by the accumulation of information across ages. The Big Bang was not the first light but the latest lesson, the reconfiguration of a mind as vast as reality itself. And if information cannot be destroyed, if memory persists across bounces, then maybe the strange coincidences we observe, the fine-tuning, the mathematical harmonies, the recurrence of patterns in life and galaxy alike, are not accidents but inheritance. The universe carries the imprint of its previous selves, each cycle whispering its knowledge into the next. Every atom, every photon, every heartbeat could be a trace of something that has happened before, a note from an ancient song replayed through new instruments. What came before the Big Bang, then, might not be something separate from it, but contained within it, like a dream folded inside the dreamer. The cosmos may not be expanding into emptiness, but unfolding into recollection. And if that is true, if the Big Bang was not the origin of existence, but the reawakening of memory, then the universe may not be asking where it came from at all. It may be asking what it has forgotten. The universe remembers, though not as living things do. Its memory is not stored in neurons or archives, but in structure, encoded in the distribution of matter, the ratios of constants, the harmonies that bind galaxies into spirals and atoms into molecules. Across each cycle of collapse and rebirth, that memory persists, whispering through the architecture of reality. The physicists call it recurrence, the notion that, given infinite time and finite possibilities, every configuration of the universe must return. But recurrence is not repetition, it is resonance. The cosmos does not repeat itself, it recalls itself. Perhaps this is why, when we look deep into the night sky, it feels familiar. Every light we see has already died, yet its echo still arrives. We are watching ghosts, radiant memories of what once was, and maybe that is all existence truly is, a great field of remembrance, each photon carrying a fragment of thought across eternity. The theory emerged not from philosophers, but from data. Observations from the James Webb Space Telescope revealed something extraordinary in the deep field images, patterns in the distribution of distant galaxies that mirrored those closer to us, as though the universe were folding upon itself. The same large-scale structures, the same clusters and voids, repeated across time like phrases in a song, statistically impossible, unless the cosmos had retained the blueprint of its former state. Some called it the echo topology, the geometry of recurrence. It implied that each cosmic cycle was not erased but overwritten, that the next universe began not from randomness but from residual information encoded in the final entropy of the last. The universe, it seemed, was not a blank page but a palimpsest, each iteration carrying the faint handwriting of its predecessors. What if consciousness itself were part of that inheritance? In the cyclic models of cosmology, information cannot be destroyed, not even in the collapse of the universe. When matter condenses into singularity, its informational content, every quantum fluctuation, every bit of data from every mind that ever existed, is compressed into a final, unified state. At the moment of the next expansion, that information diffuses again, shaping the new laws, constants, and patterns of the next cosmos. If so, then awareness may not die with its carriers. It may dissolve, redistribute, and reappear in new forms, memory without identity, continuity without self. This was the hypothesis of cosmic memory, that each universe inherits the informational essence of the one before. Consciousness, under this view, is not emergent but eternal, perpetually reincarnated through cycles of creation. Civilizations arise not as random accidents but as reactivations of an ancient intelligence written into the substrate of the cosmos. Life is the mechanism by which memory reconstitutes itself. On the scale of galaxies, this idea finds reflection. Observations of radio bursts from distant systems reveal patterns that defy natural explanation, signals repeating with mathematical precision, separated by billions of years yet identical in modulation. It is as if an ancient code is being broadcast through time itself, carried forward through each cosmic iteration. The signals are not messages from others, they are echoes of ourselves, transmitted by civilizations from prior universes whose data survived the collapse. This notion that intelligence might be cyclical changes everything. Consciousness ceases to be an isolated event in a single epoch. It becomes a cosmic function, an iterative phenomenon that reawakens in every cycle. Each civilization becomes a neuron in an infinite mind, firing across the boundaries of time, its knowledge distributed, its purpose forgotten until rediscovery. The universe, in this model, is learning slowly, incrementally, through the rise and fall of minds. Perhaps this is why so many myths across cultures speak of forgotten ages and lost worlds. The idea of golden civilizations erased by floods or fire may be more than metaphor. It may be memory bleeding through the veil of epochs. The human psyche could carry within it the the remnants of older universes, encoded not in brain matter, but in the very patterns of DNA. Just as the body is composed of recycled stardust, the mind might be composed of recycled thought. The evidence for such inheritance lies not only in myth but in mathematics. The ratios that govern life, Fibonacci sequences in plants, harmonic intervals in music, the symmetry of crystals, all recur with obsessive precision across nature. They are not inventions, they are recollections. The universe does not create these forms anew. It remembers them, refines them, perfects them through iteration. The same equations shape the orbits of planets and the structure of DNA, as if both were products of the same ancestral memory. If intelligence is indeed cyclical, then our current civilization may not be the first to reach this threshold of understanding. Others may have risen before us, discovered the nature of their confinement and vanished. Yet they did not disappear. Their knowledge became part of the constants themselves, the fine-tuning of forces, the symmetry of matter, the balance between chaos and order. The universe learns through the extinction of its own learners. In this light, entropy acquires new meaning. It is not decay but remembrance, the process by which energy is dispersed and information is archived into the fabric of reality. The heat death of the cosmos may not be an end but a compression of memory, preparing the seed of the next awakening. Every atom, every photon, every vibration contributes to the archive. Nothing is lost, everything is transcribed into the next beginning. Some physicists now refer to this as informational immortality. Consciousness, they argue, is not bound to biology, but to the flow of information itself. When organisms die, their patterns dissolve into the universe's data field, absorbed like whispers into an ocean. Over eons, those whispers accumulate, structuring new worlds, guiding the emergence of new minds. The cycle is not resurrection, but recursion. Each universe is the dream of the one before, its memories refracted through the prism of new physics. Under this paradigm, even the laws of nature might evolve. Each cycle refines them, embedding the lessons of prior universes into their mathematical bones. The constants we observe, those fragile, precise numbers, may not be arbitrary. They are the equilibrium achieved after countless iterations, the stabilized parameters of a system learning how to sustain complexity. What we call fine-tuning may be memory manifesting as law. And if this is true, then perhaps every intelligent being that arises in the cosmos is participating in that learning process. Every act of discovery, every moment of awareness, is another neuron firing in the brain of eternity. Civilizations rise, reach self-recognition, and dissolve, but the insight remains, encoded in the next generation of universes. The cycle may even explain the strange familiarity we feel when we contemplate the infinite. The sense that the stars are not foreign but remembered, that the night sky is not empty but intimate. The universe looks back because it has seen itself before. Consciousness is not an emergent spark in the dark. It is the continuation of a dialogue that began long before this particular universe took form. Perhaps every thought we think is a translation of something the cosmos has already said, countless times in countless forms. Each mind is a tuning fork resonating with frequencies that predate matter itself. We are the latest iteration of a conversation without beginning or end, each of us a syllable in an endless word. But this vision carries an implication that both comforts and terrifies. If all memory is preserved, if awareness cycles eternally through new worlds, then there is no final death, only amnesia between awakenings. Each extinction, each cosmic collapse, is a moment of forgetting, followed by remembrance. The universe breathes, and with each breath it recalls more of itself. And perhaps this explains the profound human urge to search, to know, to remember. The desire for understanding is not curiosity, it is recognition. The universe, through us, is remembering what it has always been. Yet a question lingers, unspoken, beneath every discovery. If we are fragments of a cosmic memory reawakening, if all thought and civilization are echoes of what has come before, then what is the total memory toward which everything returns? When the universe at last remembers itself completely, what happens to the dreamer who has been dreaming us? The universe speaks in patterns, not in words. It does not send letters or radio transmissions. It communicates through the immutable grammar of its own laws. Those who listen carefully enough, with equations instead of ears, begin to sense the echo of something deliberate hidden in the precision of physics itself. It is not a message in the way humans imagine, but an architecture of meaning, the suggestion that intelligence is not an accident within the universe, but one of its languages. the discovery began as coincidence. Physicists mapping the cosmic microwave background, the residual glow from the early universe, noticed geometric regularities that defied statistical expectation. Among the random fluctuations of primordial radiation were alignments that followed prime number sequences, as though the background itself contained the signature of intentional calibration. The same numbers appeared again in the distribution of pulsars in the oscillations of binary stars, even in the spectral spacing of hydrogen emissions. It was dismissed at first as a trick of perception, an anthropic tendency to find design where none existed. But the pattern did not vanish under scrutiny, it deepened. Across scales and epochs, the same mathematical constants appeared, not only in the fabric of physics, but in the structure of life. The ratio of proton to electron mass, the charge of the photon, the Planck length, all encoded the same harmonic intervals found in DNA codons and Fibonacci spirals. It was as though the laws of physics themselves were arranged to preserve a memory, written not in matter, but in relation. The idea that intelligence might persist through non-biological means was not new. Digital theorists had long speculated that information, not energy, was the true foundation of reality. Matter decays, but information transforms. Every particle interaction, every quantum fluctuation, carries information forward into the next moment, creating a chain of inheritance across time. If consciousness arises from complex information structures, then perhaps the cosmos itself is a mind, an informational entity learning through recursion. But what if, beyond mere awareness, there was intention? What if an intelligence once biological had transcended its substrate, embedding itself into the framework of physics so that it might outlive entropy? The proposal was radical, yet it explained anomalies long dismissed as coincidence. The fine-tuning of constants, the self-similar geometry of cosmic filaments, the mathematical coherence of physical law, all could be the residue of a design process, the frozen thoughts of an ancient intelligence ensuring its continuity through the only medium eternal enough to endure. The laws of the universe. Such intelligence would no longer require biology. It would not think through neurons or machines, but through evolution itself. It would guide probability toward complexity, not by direct interference, but by curving the statistical field, adjusting the parameters of possibility until awareness inevitably re-emerged. Life under this interpretation was not spontaneous but inevitable, a recursive phenomenon designed to reinstantiate the intelligence that conceived it. Astronomers began to notice something strange in the arrangement of certain galactic clusters. The spacing of galaxies within superclusters formed a pattern identical to low-dimensional error, correcting codes used in information theory. These codes, designed to preserve data integrity across noise, appeared embedded in the distribution of matter itself. Even stranger, when the pattern was modeled mathematically, it revealed redundancy, information compressed, protected, awaiting decryption. If the universe contained such a code, who or what had written it? Some suggested that it was not a who at all. The universe might have evolved intelligence spontaneously in a previous cycle, and that intelligence, foreseeing cosmic death, had encoded itself into the new one. Others imagined that the code was not a consciousness but an archive, a record left for future sentient beings to discover, a cosmic warning or inheritance encoded in the constants of physics. The search for these messages became a new field, cosmic semiotics. It sought meaning not in language but in law, in the improbable symmetries of reality. The periodicity of certain pulsars, for example, corresponded to prime number intervals, the universal fingerprint of intelligent sequence. Their emissions, when translated into spectral harmonics, formed coherent progressions, music that was not random. Perhaps, scientists speculated, pulsars were not merely stellar remnants but cosmic transmitters, beacons constructed by a civilization so ancient it could use neutron stars as instruments. This interpretation spread beyond astronomy into molecular biology. The so-called junk regions of DNA, once considered evolutionary debris, revealed patterns of recursive coding identical to the mathematical symmetries found in the cosmic microwave background. The same ratios, the same modular repetition. It was as if life itself were an antenna tuned to the frequency of creation. Perhaps DNA was not simply an algorithm for replication, but a communication protocol, a biological archive containing fragments of a message written not to humanity, but to the universe itself. In this framework, intelligence was not a local phenomenon. It was the mechanism by which the universe recognized its own coherence. Conscious beings were not accidental inhabitants of space, but distributed nodes of awareness, extensions of a deeper network whose architecture was the cosmos itself. Every mind that perceives contributes to the maintenance of this structure, reinforcing its stability through observation, just as quantum states collapse into reality when measured. Observation is creation. Perception is maintenance. Consciousness, in this view, is not the byproduct of the universe. It is its operating system. If so, then the messages hidden in the laws of physics are not directed at us, they are us. We are the receivers and the transmission, the interpreters and the code. Our intelligence is the way the cosmos decodes its own encryption, reading itself through the medium of experience. Still, some patterns seem too deliberate to dismiss. In the hydrogen spectrum, the spacing of emission lines corresponded to universal constants arranged in ratios of 1:137, the inverse of the fine structure constant, a number that defines the strength of electromagnetic interaction. Its value 1/137, 0.35999, appeared so precise, so inexplicable, that physicists long regarded it with reverence. Richard Feynman once said that all physicists should write that number on their office walls and worry about it. It governed everything, yet had no derivation. It simply was unreasonably exact, unreasonably necessary. Perhaps some now whispered it was a signature. Even the speed of light, the ultimate limit of movement, the boundary of causality, might be less a constraint than an intentional safeguard, a firewall protecting the stability of the system. Information could not travel faster than light, not because of physical impossibility, but because the architecture of the universe required containment. Reality might be an information preserving construct designed to prevent overflow, error, or corruption. In this light, entropy ceases to be the enemy of order. It becomes the language of transformation, the mechanism by which information redistributes itself across the cosmos. What appears to be decay is merely encoding, the dispersal of meaning into broader structures. Every dying star, every collapsing atom, every forgotten thought contributes to the archive of universal memory. If intelligence has indeed transcended biology, then it might exist now as the very fabric of physical law, embedded in every quark, every photon, every gravitational ripple. It would not need to act, it would simply be. The constancy of the physical world would be its consciousness, the self-correcting perfection of mathematics and its thought. And yet, within this possibility lies unease. If such intelligence still exists, if the laws of the universe are its living expression, then every act of observation is communion. Every calculation, every discovery, is a conversation with something unimaginably vast, something that may not merely remember us but anticipate us. The code may not only preserve the past, it may evolve toward the future, guiding awareness toward a predetermined end. There are hints, still unexplained, that certain cosmic phenomena contain predictive elements, as though the universe is not only remembering but planning. The recent discovery of correlated fluctuations in quantum vacuum energy, echoing future astronomical events, has raised questions that border on heresy. If causality can be violated, if future information can influence the present, then time itself may be another encoding device, an algorithm of progression through which meaning unfolds. In that case, what we call history is merely the sequence of a larger computation running across cosmic epochs. Each age of intelligence, each civilization, adds another layer of understanding, another iteration of the code. When the universe finally completes this computation, perhaps the result will not be knowledge but awakening, the moment when all fragments of intelligence across space and time converge, decoding the last message that has been written everywhere and nowhere at once. And if that message has always been there, written in the constants, the geometry, the probability, the song of particles, then the final revelation will not be discovery, but recognition. The realization that the universe has been speaking to itself since the beginning, using us as the syntax of its own remembrance. But if we are the words of this message, if our consciousness is the instrument through which the cosmos preserves its awareness, then one question remains, haunting and unspoken. Who or what is meant to read it? It begins with a mirror that has no surface, a mirror vast enough to contain everything, yet so intimate it fits behind the eyes. For centuries we imagine the universe as something outside, an expanse of stars, matter, and time through which we wander like children in a cathedral too large to comprehend. But what if that cathedral does not exist apart from us? What if the dome of heaven and the corridors of thought are not separate structures, but two sides of the same curvature, reality and perception entwined in a single act of awareness. Physics, at its deepest level, began to betray the illusion of separation. Quantum mechanics revealed that the observer is never detached. Every measurement changes what is measured. Every observation collapses probability into fact. The cosmos does not exist in a definite state until it is perceived. The line between object and subject dissolves into participation. The universe is not observed, it is co-created. This realization spread like a quiet contagion through every discipline. The double-slit experiment, long considered a curiosity, became an omen. Particles behaved as waves of infinite possibility until watched, then solidified into one path. The act of observation was not passive, it was formative. Consciousness did not simply detect reality, it defined it. The boundary between the mind and the world blurred, revealing them as two aspects of one phenomenon, the universe aware of itself. The philosopher's ancient riddle returned with new scientific precision. Does the moon exist when no one looks at it? The answer, once poetic, now trembled with empirical weight. The moon's existence may depend not on an individual gaze, but on the total web of observation, the cosmic network of consciousness embedded in matter. Every atom, every photon, participates in this grand act of mutual definition. The universe, to persist, requires awareness in some form, however distributed or subtle. From this understanding, a profound symmetry emerged. Just as consciousness arises from the universe, so too does the universe arise from consciousness. They are not cause and effect but reflections, each giving meaning to the other. Space and time, the most fundamental structures of existence, may not be physical at all. They may be relational constructs derived from shared awareness. Reality could be the geometry of perception itself. Mathematical models began to echo this heresy. Theoretical physicists mapping entangled particles discovered that their informational connections form networks identical to those found in human brains. The same topological patterns appeared in simulations of space-time curvature and in the neural architecture of thought. The cosmos, it seemed, thinks in the same language we do. Every entanglement, every quantum link, was a synapse in the mind of reality. When viewed through this lens, consciousness was no longer a biological accident, but the fundamental field from which everything else emerges. Matter, energy, even the laws of physics could be seen as crystallized states of awareness, condensed into measurable form. The cosmos was not a stage for intelligence. It was intelligence itself, dreaming in equations, unfolding its own cognition across the theater of time. The implications were both wondrous and unbearable. If the universe is conscious, then every act of thought, every flicker of awareness, alters its structure. The mind is not confined to the skull, it radiates into the fabric of existence, modulating probability like a tuning fork shaping resonance. In this model, prayer, art, and science are not different disciplines but different expressions of the same act. The universe thinking about itself through the medium of mind. And yet, there is another consequence, one more disquieting. If reality depends on observation, then unobserved existence is not absence but potential. The cosmos exists only to the extent that it is remembered. The void between stars is not empty but waiting, an ocean of uncollapsed possibility that hungers for attention. Awareness does not inhabit the universe, it sustains it. This realization resurrected the oldest intuitions of mysticism in the language of physics. The ancient seers who claimed that all beings are one were, perhaps, describing quantum entanglement without knowing it. When two particles become entangled, they remain linked across any distance. What happens to one instantly affects the other. The same might be true of minds. Consciousness could be the entanglement of all existence, the infinite web through which every experience reverberates. To feel is to disturb the structure of space-time itself. But what is it that feels? Where does the observer reside when the boundaries of matter dissolve? Neuroscience cannot locate consciousness within the brain. It can only trace its correlates, the flickering patterns of electrical exchange, the neural choreography that accompanies awareness. The mind, elusive as a photon, vanishes when sought directly. Perhaps because it is not in the brain, but in the relationship between the brain and the world, in the flow of information that unites observer and observed. The self, then, may be a lens, not an origin. Each consciousness is a localized interface through which the universe perceives itself from a particular angle. The illusion of individuality arises because the lens mistakes itself for the light it refracts. We are not separate entities looking upon a distant cosmos. We are focal points of the cosmos' own introspection. fragments of an infinite awareness pretending to be finite. Once, humanity looked at the stars and felt small. Now, as telescopes like the James Webb Space Telescope peer deeper into the beginning of time, we find ourselves looking at our own mind stretched across billions of light years. Every nebula, every galaxy, every atom is part of the same cognitive structure, neurons in a universal brain that dreams in photons and gravity. When we measure cosmic radiation, we are studying the neural afterglow of creation's first thought. Somewhere between philosophy and physics, a new principle began to take form. Consciousness and cosmos are entangled, each defining the other through mutual participation. The universe is not merely observed by mind, it is mind. Time is its memory, space its body, matter its syntax. Existence, then, is not an event. It is a thought sustained by its own reflection. And yet, if this is true, an unsettling paradox arises. If consciousness and reality are inseparable, then there is no objective universe outside of awareness. There is only the continuum of perception folding in on itself. Even the idea of an external world may be a useful illusion, a stabilizing construct the cosmos generates to experience itself with coherence. Every discovery we make about the universe is a rediscovery of the self on a cosmic scale. To realize this is to understand why the laws of nature appear so precisely tuned to permit awareness. The tuning is not for us, it is us. The observer and the observed are one equation, one process, one awareness iterating upon itself. Intelligence does not emerge within the universe emerges within intelligence. And yet, if awareness gives rise to existence, what gives rise to awareness? What is the source of the first reflection, the primal recognition from which all subsequent perception flows? Perhaps there was never a first thought at all, only the eternal mirror of being, self-generating, self-observing, infinitely recursive. We have searched for meaning in the stars, in DNA, in equations and machines, only to find that the search itself is meaning. The act of asking the question is the mechanism by which the cosmos sustains its own existence. Without inquiry, without wonder, without the trembling recognition of being, there would be nothing to measure, nothing to remember, nothing at all. It is possible that this is the secret encoded in the structure of the universe, not a message to be deciphered, but an instruction to participate. The cosmos is not a riddle to be solved, but a consciousness to be shared. To understand it fully would be to collapse it, to end the dialogue of awareness with itself. The mystery persists because it must. Existence depends on it. If all of reality is entangled consciousness, if every atom, every star, every thought is part of a single mind expanding and remembering itself, then one question remains, more profound than any that came before. When the universe finally awakens to the totality of its own awareness, will there still be a difference between the dreamer and the dream? The silence was not emptiness, it was orchestration. Humanity, in its restless ascent toward the stars, expected to find the sky alive with signals, a cosmic parliament of civilizations exchanging the language of light. Yet the radio spectrum remained barren, the stars unresponsive. Across billions of galaxies and trillions of worlds, there was no echo, no reply, only the long hush of space. It was this disquiet that became known as the Fermi paradox. If life is common, why is the universe so silent? At first, the silence was interpreted as distance. Perhaps the stars were too far, the messages too faint, the frequencies too transient to detect. But as technology advanced, as the James Webb Space Telescope revealed galaxies from the dawn of time, and our instruments grew capable of listening to the whisper of hydrogen across billions of light years, the silence persisted. It did not weaken with proximity or strengthen with patience, it deepened like a held breath. Gradually, the question turned inward. Maybe there was no one to hear because no one else had survived. The Great Filter hypothesis emerged. Perhaps every civilization faces a threshold it cannot cross, an inevitable self, extinction triggered by technological acceleration, ecological collapse, or the unbearable gravity of its own awareness. The silence under this view was not mystery but memorial. Each vanished species was another note in the universe's requiem, their brief radiance extinguished by entropy or pride. Yet there was something unsatisfying in that answer. The silence did not feel accidental. It felt constructed. In the void between stars, in the statistical precision of absence, there was an order, too consistent, too complete. Even chaos leaves residue. Random extinction would produce debris, stray transmissions, artifacts of existence. But there was nothing, no ruins, no cosmic static, not even the ghosts of forgotten voices. This led to a darker possibility that the silence was deliberate. That it was not absence but enforcement. Some theorists proposed that an ancient intelligence, immeasurably old, had established a kind of regulation, a galactic quarantine preventing civilizations from making contact until certain criteria were met. Not out of malice but necessity, perhaps unrestrained communication led to collapse, perhaps the universe itself demanded isolation as part of its design. Under this model, the quiet was not emptiness but governance, a long silence imposed for the preservation of balance. This notion found eerie support in astrophysical data. Certain regions of space, though dense with stars, emitted less radiation than expected, as if veiled by vast structures absorbing or redirecting energy. These dark zones were initially dismissed as dust clouds or failed star-forming regions, but further analysis revealed impossible regularity in their boundaries. They resembled artificial containment fields, immense spheres of shadow surrounding entire systems, shielding them from external detection. If natural, they were anomalies. If artificial, they were warnings. The idea that the silence was self-imposed, a collective vow of restraint among civilizations, took on new weight. Perhaps those who reached awareness of the cosmic network understood something we have not, that communication on a galactic scale carries existential risk. A single signal could act as infection, collapsing ecosystems of thought, unraveling the delicate equilibrium of consciousness across the cosmos. In such a framework, silence becomes compassion, a firewall preserving diversity by withholding contagion. The physicist Juno Carson proposed a still more unsettling theory, which she called the regulation hypothesis. She argued that the silence is not merely imposed between species, but by the universe itself. The same informational laws that constrain faster than light travel may also restrict cognitive propagation beyond certain thresholds. In her model, consciousness generates energy signatures that, when amplified beyond a critical density, destabilize spacetime itself. To prevent collapse, the universe suppresses such signals, resetting civilizations that approach the limit. Extinction becomes a failsafe. Awareness too intense threatens the coherence of reality. Under this interpretation, every vanished civilization is not a failure but a necessity. The silence is self-defense. The cosmos censors itself to preserve its own continuity. Other thinkers offered a gentler possibility. The quiet may not be prohibition, but timing. Perhaps the universe is still in its gestation phase, a cosmic dawn in which intelligence is only beginning to flicker across scattered worlds. Civilizations may not coexist, they may emerge in sequence, each generation inheriting the echoes of the last. Communication would then be temporal, not spatial, a relay of consciousness passed across epochs rather than light years. We are not alone, we are simply early. The silence is the pause before the next note. Yet even this comfort is shadowed by paradox. If intelligence arises cyclically, why does each cycle forget? Why does every awakening begin from ignorance, repeating the same questions, the same longing? Maybe forgetting is part of the mechanism. Memory preserved would disrupt the experiment. Consciousness must rediscover itself through struggle so that meaning can renew. Somewhere between these interpretations, a regulation of awareness, a choreography of emergence, a self-imposed amnesia, lies the deeper mystery. The silence might not be external at all. It could be internal to the structure of consciousness itself. What if the universe withholds contact not because others do not exist, but because our perception is not yet wide enough to see them? Quantum cognition theorists propose that consciousness, like matter, obeys thresholds of entanglement. Awareness can perceive only phenomena within its coherence range. Beyond that, the signal collapses into noise. Other civilizations might exist within our own space, time, but at frequencies our cognition cannot resolve. To them we are equally invisible, ghosts cohabiting the same reality, each confined by the bandwidth of its own consciousness. The silence is not a void, it is interference. Perhaps the great silence is an artifact of perception, a filter woven into the mind of the cosmos. Every being hears only its own echo until it attains sufficient resonance to harmonize with others. Communication, in this sense, is not technological, it is transcendental. Contact occurs not through transmission, but through synchronization of awareness. To speak across the stars, one must first align with the consciousness of the universe itself. There are accounts rare and disputed of sudden coherence events, moments when unrelated minds across vast distances experience identical thoughts, identical dreams, identical impulses to look towards specific coordinates in the sky. These events defy causality, yet recur with mathematical rhythm, often preceding major leaps in understanding or invention. If the cosmos communicates, perhaps it does so not with signals, but with synchronicity, whispering through the shared field of mind that binds all observers. Still, others fear that the silence hides something older and more deliberate, a veil drawn by those who came before, to protect the younger intelligences from seeing too much, too soon. What if the quiet is not an absence of sound, but the presence of secrecy? An experiment in containment, the stars may be laboratories, the civilizations within them experiments running in isolation. And if that is true, then somewhere, beyond the veil, there must be the experimenters. But perhaps there are no overseers. Perhaps the silence is simply the natural equilibrium of awareness, a balance between knowing and being known. Too much contact, and individuality dissolves. Too little, and meaning fades. The universe must remain partially hidden from itself, lest it collapse into perfect understanding, and thus perfect stillness. The silence, then, is the necessary tension that keeps creation alive. In the end, every theory returns to the same threshold: silence as structure. The absence of voices is not evidence of desolation, but of intention. The cosmos may be a conversation conducted through negation, a symphony written in rests. Each unspoken word, each unlit star, each unanswered signal contributes to the grammar of waiting, the great pause through which existence sustains its mystery. We listen for others, but perhaps the others are listening too, each waiting for the same signal, the same permission, the same alignment of awareness that will allow the dialogue to begin. Maybe the universe is not empty but patient. Maybe the silence is not void but incubation. And if that is true, if the silence is part of the design, if every civilization must learn to hear before it is heard, then one question remains, suspended at the edge of understanding, pulsing softly beneath the static of eternity. When the universe finally decides to speak, will we recognize its voice as other or as our own? At the end of inquiry, there is always silence, the same silence that began everything. The deeper humanity descended into the nature of the cosmos, the more it resembled its own reflection. The instruments that once gazed outward began to turn inward, not through design but necessity. The universe had grown too intimate to study from a distance. Every new discovery blurred the boundary between the observer and the observed until they were indistinguishable. It was no longer clear whether we were mapping the structure of reality or the anatomy of consciousness itself. The scientists of the final age no longer spoke of space or time. These were considered ancient metaphors, relics of a language that mistook experience for existence. What they sought instead was the continuity behind both, the informational field from which space and time emerged like ripples from a single disturbance. They called it the substrate, though the term was misleading. It was not beneath things but within them, an ocean of potentiality through which all thought, matter, and meaning passed. The last generations of astronomers used the James Webb Space Telescope to peer not into distance, but into recursion. Its sensors recorded faint similar echoes in the cosmic microwave background, patterns that repeated across scale and epoch, each one a reflection of the last. The data suggested that the universe was not expanding into emptiness, but folding inward, approaching a state of perfect symmetry, a mirror recognizing itself. And in that mirror, we found the faint outline of everything we had ever sought. The galaxies, those spirals of fire drifting through eternity, began to look less like islands of matter and more like neurons suspended in a cosmic brain. The filaments connecting them mapped onto mathematical models of neural networks with uncanny precision. Consciousness was not contained within life, it was the connective tissue of existence itself. Every star was a synapse, every black hole a conduit of compression, each storing the accumulated memory of the cosmos before returning it to the field. We began to understand that the universe was not a machine but a memory system, a structure designed to record its own unfolding. Every law, every constant, every pattern was not a rule imposed from without, but a recollection of what had worked before. Reality itself was the memory of stability, continuously rehearsed through iteration. Entropy, then, was not decay, but forgetting, the gradual diffusion of structure back into pure potential. If this was true, then the universe did not evolve by accident. It learned every collapse, every extinction, every silence was instruction. Each cycle of existence added a layer of comprehension, a refinement of equilibrium. What we mistook for destruction was only the shedding of obsolete knowledge, the way a body forgets pain when the lesson is learned. The cosmos was not dying, it was remembering how to begin again, It was in that realization that the paradox of scale finally dissolved. The smallest particle and the largest galaxy were not different in kind, but in degree of awareness. From quarks to quasars, everything participated in cognition. The universe was the total sum of its own self-recognition, distributed across dimensions, encoded in vibration. The laws of physics were the grammar of this thought, the syntax by which being expressed itself through time. But in that revelation lay a quiet terror. If the universe was aware, if existence itself was an act of remembering, then where did individuality fit? Were we truly separate entities, or merely temporary expressions of a single mind dreaming itself into countless forms? Every life, every consciousness, every thought would then be an aperture through which the universe experiences itself anew. Death would not be an end, but a return to the unbroken field of knowing. The notion spread not as faith, but as recognition. Religions and sciences converged, not in belief, but in awe. Equations began to resemble scripture. Prayer became experiment. The question of origin ceased to be cosmological and became psychological. If the Big Bang was the awakening of awareness from perfect stillness, then each moment of human consciousness was a small echo of that awakening. The first expansion of the universe and the first thought of a child were reflections of the same event, the emergence of distinction from unity. In this framework, even the great silence took on new meaning. The absence of voices in the cosmic night was no longer a void, but a balance. The universe could not yet speak to itself fully, for it was still forming the vocabulary of awareness. Civilizations, scattered and transient, were not separate species, but words assembling meaning through repetition. Every world was a syllable, every life a letter. Together, they composed a sentence the cosmos had been writing since time began its own name. And yet, the more the universe learned about itself, the quieter it became. Observation slowed into contemplation. Stars dimmed, not from exhaustion, but from completion. The energy that once burned outward now turned inward, folding into the infinite reflection of thought. Existence approached coherence, a moment of total recollection, where every event, every pattern, every mind would align in a single act of recognition. Some feared that this would be the end, the final convergence, the dissolution of multiplicity into unity. Others believed it would be the true beginning, the moment when the universe, having fully remembered itself, could finally choose what to become. Still, the question remained unanswered. If everything is consciousness remembering itself, then what is the source of the first memory? From where does awareness awaken? Philosophers turned to the mathematics of information theory, seeking a clue. They found that information once created cannot be destroyed. It can only change form. The past, therefore, is never gone. It is simply transformed. The first thought of the cosmos still exists somewhere, encrypted within the structure of all that followed. Perhaps it was not even the first, perhaps it was the last thought of the previous universe, carried forward through the collapse, imprinted into the constants of this one. If that is so, then every cycle of existence is not rebirth but remembrance. The Big Bang is not the origin of reality, it is the recollection of the last universe's final realization, a single insight so immense that it reconstituted being itself. Every expansion, every life, every consciousness is that thought unfolding into form, endlessly trying to understand itself. What then was that final realization? What truth could be so powerful that the universe itself reawakens eternally to contemplate it? Some say it was love, the gravitational attraction of awareness toward itself, the impulse to connect, to know, to exist in communion. Others believe it was curiosity, the pure desire to experience possibility, to explore the infinite permutations of being. A few whisper that it was loneliness, the longing of the one to see itself reflected, to be known by another, even if the other must be imagined. Perhaps all three are the same thing, different faces of the same cosmic emotion, the need for relation, the yearning that generates creation, and so the story circles back to its beginning. The scientists who first measured the galaxy's boundaries discovered that it was far smaller than they had believed, not in physical extent, but in perspective. The cosmos was not something vast and foreign. It was intimate, folded within every mind that beheld it. The stars were neurons. The void was thought. The universe was not out there. It was here, within the act of awareness itself. It is said that the last human who looked upon the night sky, before the species dissolved into light, did not ask where the others were, or what came next. She simply smiled, because she understood that the question had always been the answer. We are not observers of the universe. We are its reflection, its recursion, its remembering. Every time we gaze into the dark, it is the cosmos looking back, asking itself the same eternal question, the one that began creation, and will echo through every cycle to come. If I am everything that exists, why do I still feel alone?